Yo, what's crackin' mates? Here is a very brief guide about how to set up a public server securely. If you are new to Linux or server administration in general, I would recommend you to take your first steps with a virtual machine instead. For anyone else who is ready to place themselves up for public scrutiny, this video is for you. The steps documented here is what I consider the bare minimum to perform on a fresh server in order to keep it safe from bad actors. There is also no need to try the login information you will see on screen, since I will have changed it by the time you see this video. First things first, it's time to rent a public server. Since I have used it for quite some time without any issues regarding my small scale projects, I'm once again going for Contabo. This is not a sponsorship, by the way. It's a hoster in Germany, but they also offer machines in other areas like the US or Asia, for example. What I'm going for is Cloud VPS 1, since it fits quite neatly what I'm aiming for. This gives you 4 virtual cores, 6GB of RAM, 400GB of SSD storage, as well as a snapshot slot. I already have one of those in the EU, and this time I'm going for one in the UK as a failover in another region. My chosen OS is Debian, since I value stability for a production grade server, but once again, pick what floats your boat. Generate your root password, which will be used for the very first login, and if you want to impersonate root afterwards. The rest are unimportant extras in my case, but if you are curious, you can of course have a look. Click next, check everything on the summary page, and then pay the toll. Afterwards you can speedrun through the annoying survey and wait for your server to be accessible after a short time. That's it for the boring part. Setup time. Let's connect the root via SSH. In my case, I didn't have an SSH client installed on my local machine yet. This can be fixed by either installing the whole SSH package, or if you wanna be frugal, the one called OpenSSH client. Try again and you should get a prompt to add the fingerprint. Type your root password and you should be in. My first course of action is to update the package index on the server and install sudo, since I won't be using root to connect for security reasons. Right after that, I change root's password to be different from what Contabo generated. Just make sure you note it down properly. Now it's time to add the user for connecting and running basic administration via sudo. Since the full name is used in certain applications for display, I give it the same value. Via usermod, I also add the user to the sudo group so I can actually use the command. The next step is probably the most crucial one for tightening the server's security, adjusting the SSHD config. The first adjustment is the port. I absolutely do recommend you to change it to something besides the default of 22. If you have never taken a look yourself, you would certainly be shocked by the amount of traffic hammering in on that port. You should take an unused port below 1024, since these can only be used by root processes. Not only will it significantly cut down the amount of authentication log being produced, it also allows us to do some aggressive firewalling, which I will talk more about in an upcoming video. The second adjustment is permit root login, which we disable in order to not have a standardized user for logging in. This could be exploited in brute force attacks or SSHD vulnerabilities. Now simply save and close the file, restart SSHD and disconnect. When trying to connect with your local machine with the same command as last time, you will see that the connection will be refused due to the port being different. A second try with the new port will not work either, because root is no longer permitted, even if you would pass the correct password. On the third try, you either change the user before the @ sign to the one you created, or you can skip it entirely if it's the same user as you are using on your local session. After successfully logging in with the new user, we impersonate root with the su command in order to do some further system administration without writing sudo all the time. You can notice that it's suddenly missing the coloration. When you echo your path environment variable, you will also see that it looks quite wrong. There is something fishy going on. Let's address the coloration first. This is a bash issue where you need to properly set the PS1 environment variable. It lacks coloration since someone in ages long past decided that it should be like that. You can copy over the needed value from your own users.bash rc and paste it in root. Since I'm already here, I also enable ls coloration as well, which just needs uncommenting of a few lines. Exit root and su again, but this time pass minus as an argument. This leads to the environment being loaded properly, which you can confirm by calling system utilities or echoing your path. The next thing on the list is checking for the health of services and networking in particular. This might be a Contabo only thing, but with them you will see that networking is in a fail state right from the get-go, which seems kinda weird since we are connected to the server. And the reason behind that is the way they set up IPv6 support. If you plan to only support IPv4, you can comment the whole dedicated block in the interfaces file out. I want IPv6 enabled and thus I can call an alias which Contabo already registered for root. With that being done, we can address the second major point for securing our system, the firewall. On Debian, the standard firewall with kernel support is nftables, and it's quite powerful too. The simple first version of the firewall I would implement can be summarized as follows. Drop all inbound traffic except for 3 conditions. Accept all localhost traffic. Accept all traffic where the connection is either already established or related to an established connection. Accept connections to the custom SSH port. If you have any other ports you need to publish, you do it here. As mentioned before, I will do a dedicated video about aggressive firewalling as a follow-up, but this one here is the bare essential I can sleep with for a few days at least. It's never a bad idea to check if the config file we just wrote is valid. Then I list the current nftables rule set, which returns empty as expected. I enable and start the nftables daemon and print the current rule set again. It should look familiar. Afterwards, I run a system upgrade which still works even after enabling our firewall. Once that's done, I install my task manager of choice, HTOP. This step is totally optional, but in my opinion, HTOP is one of the most essential tools of a system administrator to get a feeling of a system state. In addition to installing it, I also set the layout like I want it to be and add meters for disk and network I/O. I call apt auto-remove to get rid of any orphan packages and then perform a reboot to restart with the latest kernel as well as an IPv6 interface. Now comes the second optional part, which I absolutely would recommend you for strong security, which is using SSH keys instead of password authentication. While we wait for the server coming back up, we can use the time to generate a key pair for doing so. This can be done using the SSH keychain utility. I'm going for add 25519 keys, which probably will slowly phase out RSA keys in the future. Any modern system should support them. The only concern you should have is if you need to connect to some legacy systems. With the SSH copy ID command, you can properly copy over the necessary data to the target server in order to use SSH key authentication. The password you have to provide here is the one for the user on the server and not for the key pair if you have given it a passphrase. If you have encrypted your key pair with a passphrase, which I would recommend you to do for security reasons, you can install the keychain utility. In essence, it's an agent for holding your keys in a secure cache, which frees you of typing the passphrase each and every time, which persists through sessions. In order for it to work properly, you have to add a line to your .bash rc, so it starts with your login. Please take note that the quotes you see me add at the very last line are in fact backticks and not single quotes. As always, this is a balancing act between security and convenience, but I think using keychain is more than secure enough while preventing me from going absolutely insane. Now we can call source.bash rc in order to reload. which will ask for the key pair passphrase. After that, we should be able to SSH to our server without providing anything at all. Now let's try in a new session to check the persistence of keychain. You should automatically see some lines written by keychain, letting you know that it was able to load a key. And once again, we are able to connect without providing any credentials at all. The only thing remaining now is adjusting SSHD config one last time. What we need to do now is to explicitly deny all forms of authentication besides pub key authentication. As soon as that's done, save and close the file and restart SSHD once more. This concludes the secure server setup guide and should prevent your machines from being owned. Check the pinned comment and video description if there are any small addendums I want to share in the future. Merry Christmas and stay tuned for more.